There we are. Woo! Yes, excellent. Everyone's awake. Thank you for coming along. My name is Matt McSpirit. I'm one of our technical product managers at Microsoft, based in the US. And my focus at Microsoft is really helping our partners and our customers understand our positioning of our virtualization, our systems management technologies, and in this particular case, how it compares and contrasts with VMware vSphere 5.1. I'm a Microsoft certified and VMware certified professional, although I bet many of you in the room are also at that level as well. So hopefully we can have a good conversation about where our strengths and also weaknesses are. I'm open, I'm honest. Where I think VMware are slightly ahead, I'll call it out. Where I think Microsoft are ahead, I'll call that out as well. And the slides are completely publicly available. So if you want to take photos, go ahead. But if you want to download the slides, you'll be able to have them as well. So nothing is hidden away. It's all accessible for you guys. So before we dive into the comparison, I want to help us focus on just where Hyper-V has come from in a relatively short space of time. If we think back to 2008, Windows Server 2008 shipped in February of that year, but Hyper-V was only available as a beta product at that time. It's only later in that year, in June, that Hyper-V and the Hyper-V role became enabled as a fully fledged supported hypervisor within the Windows Server OS. And ever since then, it's been evolving. But a few months after that, we actually released a free product called Hyper-V Server. And Hyper-V Server, as I said, is free to download, and it contained just a subset of the Windows Server operating system specific to running Hyper-V. So you couldn't turn on domain controller or terminal server roles and features. It was very much Hyper-V and that was it. But it also lacked a certain number of capabilities relating to resiliency. So there was no clustering, for instance, which made it suitable for perhaps some test and dev environments, but not really for production workloads that needed a resiliency level. But fast forward a year, and Windows Server 2008 R2 came along, and that really put a stake in the ground for Microsoft and said, look, we're serious about this virtualization stuff now. We're giving you features like live migration, free in the box, when at the time in competitors' technologies like vSphere, it was still one of those features that was only available in some of the higher SKUs. And it's amazing to see now in vSphere 5 and 5.1 how those features are dropping down into some of the lower SKUs, so then becoming more available to more broad customer sizes and segments. We introduced better management of storage. So instead of having one VM per LUN on your storage array, which was a utilization nightmare, we improved. And we brought out cluster shared volumes, which gave us a level of parity with what VMware were delivering with VMFS. They're different in their approaches, but they achieve the same goal of providing multiple virtual machines on individual LUNs of storage, with all hosts being able to access those VMs at any point within the clustered environment. There were lots of incremental performance improvements, hot add of storage, flexibility around moving VMs between slightly different hosts, using processor compatibility. So I couldn't move a VM from Intel to AMD, that would be magic, but I could move a VM from a host with a newer Intel processor to one that's slightly older. Now VMware in their processor compatibility equivalent, Enhanced vMotion, they've got a little bit more granularity about that leveling within the processor. So there's still a bit of an advantage there if you are having hosts that are slightly different within the same cluster. Something to be aware of. But then we fast forward again, and we launched Service Pack 1. Now, service packs don't normally bring, or at least at the time, they didn't normally bring features. We have to think back to XP SP2, where features were introduced as part of the service pack. But for Windows Server 2008 R2, there were some significant features introduced for Hyper-V. Dynamic memory brought us an answer to memory over commit. And we'll talk a bit about those contrasting techniques when we get into the demo, into the presentation a bit later on. And it also brought us a technology called RemoteFX, which was specifically used for VDI deployments, to enable you to create a virtual machine and connect it directly to a graphics card in that physical server, providing a much richer user experience for people who wanted to do CAD or modeling or any kind of high graphically intense workloads. And that kind of brought us up to a point where we were at a good place in the market. Hyper-V's share was growing, but when 2012 came along, the excitement, the anticipation, and just the awareness of Hyper-V just seemed to rocket. And when we go forward to 2012 R2, it's even going to grow even further. So when we introduced Hyper-V in 2012, there was features that improved the scale, spaces for storage enhancements, metering, quality of service, a ton of migration enhancements, many of which we're going to talk about in the session. Network virtualization. It is a transformative release from a virtualization perspective. And for many of the analysts and many of our customers and partners, it brought us on par with many of the expectations that they had with vSphere at a fraction of the cost. But let's dive in and let's look at some more of those capabilities and see just how Hyper-V stacks up against vSphere. And we're going to compare across 4 key areas. We're going to look at scale and see what features drive higher performance in both versions or both products. We'll look at some of the security and multi-tenancy, particularly as more and more organizations are looking to become or utilize service providers or run multi-tenanted environments within their enterprise. Security is becoming very, very important. We'll look at flexibility, moving stuff around. What workloads can I run in the environment on Hyper-V versus vSphere? And finally, we'll wrap up with some resiliency discussions, focusing on local resiliency, HA clustering, and then also geographical resiliency with technologies like replication. So, if we start with scalability, if we think where we were in 2008 R2, and we think where we are in 2012 R2 now, 2012 R2 hasn't changed any of the numbers in terms of Hyper-V from a scalability perspective. So these are valid for both 2012 and 2012 R2. But you'll see the leap from 2008 R2 to 2012 was phenomenal in terms of physical host sizing, in terms of VM sizing, which is probably the most significant, and then also in cluster sizing. So if you think about where we came from a host perspective, 64 logical processors, which for most people is still more headroom than they have on their physical servers today. If we think about 64 logical procs, if most people are buying 2 processor systems, 8 cores maybe as a standard, 16 logical processors per socket, that's a total of 32 logical processors. That's plenty for Hyper-V in 2008 R2. And yet we're saying in Hyper-V 2012 and R2 that we support 320 logical processors. That's huge, huge scalability for the future. There are very few instances and customers that I've ever met who have a server anywhere near as big as that. Somebody in Microsoft must have a server as big as that because we've tested it. So somewhere, somebody must have one. I would love to get my hands on it because it's probably the same server that has 4 terabytes of RAM, which puts it in quite an expensive category. The DIMM sizes will be quite big and the price will be quite high. But if you need that kind of scalability for your systems, then Hyper-V is right there to support it. But more importantly, when we start to think about the VM sizing, 64 virtual procs in 2012, huge scale, no licensing restrictions. So whether I use the free Hyper-V server, whether I use Windows Server Standard with Hyper-V, or Data Center, it doesn't matter, it's the same. I can use 64 virtual procs per VM, no restrictions. So I've got that flexibility. That's a little bit different from vSphere, where as you drop down the SKUs, you start to lose some of that higher end scale. But 64 isn't going to be used by everybody. But at least it's more than the 4 that existed with Hyper-V in 2008 R2. So it really bumped us up on that front. The memory per VM, again, huge scalability, allowing us to run big, big workloads. You saw the kind of workloads in the SQL demonstration this morning, the in-memory databases, the powerful workloads we're now virtualizing, the SAP announcement. That kind of stuff is unlocked. Now we're really displaying and delivering this kind of scale within Hyper-V in 2012. And we think about the cluster sizes. Think about what we had in 2008 R2. 16 physical servers, a maximum of 1,000 VMs. Plenty for most organizations. But there are customers now turning to Hyper-V in 2012 because of the kind of numbers we can provide on our clustering scale in 2012 and 2012 R2. 64 physical systems connected together with shared storage, supporting up to 8,000 VMs. So hugely, hugely scalable. But then if we think, how does this stack up against vSphere? And the comparison that we've put together here, on the left-hand column, Hyper-V. That could be Hyper-V Server, it could be Windows Server Standard with Hyper-V, it could be Data Center with Hyper-V. Doesn't matter. It's the same. But on the vSphere side, I've separated out the pure play hypervisor that you can download off the web. Anybody can grab it, download it, and you can run that on a physical system. And I've separated that from vSphere 5.1 Enterprise Plus, which is the highest end edition of vSphere. It may be one that many of you are running, and that's where a comparison will fit together. And you'll see that Hyper-V is a scalability platform, hugely scalable, double the scalability in some cases over the vSphere hypervisor and vSphere 5.1 Enterprise Plus. But at the end of the day, does it matter whether I've got support for 160 or 320 logical procs? Because it's more than enough on both sides. So we're really delivering scale across the board, whether it's Hyper-V or the vSphere hypervisor within vSphere Enterprise Plus. Where it gets a little bit more specific is where we start to look at the virtual procs per VM. 64 for Hyper-V, 8 for the vSphere hypervisor, that free edition. And it's only when you go to vSphere Enterprise Plus that you get the 64 virtual procs. You drop it down, you go to 32 with Enterprise, you drop it down further to Standard, and you're into 8. So if you've got a requirement for a niche workload that needs additional CPU and processing power, then Hyper-V is a great fit for that, as is vSphere 5.1 Enterprise Plus. Now, just because you can give a workload huge amounts of virtual CPUs doesn't mean you should. It can negatively impact performance if it's not right for the workload. But notice when we are scaling out the CPU, we need to think about other things. We need to think about things like NUMA. And guest NUMA, as you create these big virtual machines, becomes very, very important. The topology that you define for that virtual machine and the way it utilizes CPU and local memory can drastically change the performance of that virtual machine. So Hyper-V and vSphere all provide that guest NUMA to ensure that you can drive the best performance for the workloads whilst using those big, big VMs, multiple procs, lots of memory. And when we think about the clustering, Hyper-V supports 64 and 8,000 VMs, like we said. No clustering in the vSphere hypervisor, the free one. I need to buy some edition of vSphere to be able to use HA, whether that's a vSphere Essentials Plus, whether it's a standard Enterprise Plus. I need to buy something. I can't get it with the free hypervisor like I can with the free Hyper-V server. So if you're thinking, how can I drive down my cost with a free hypervisor and still gain some of the enterprise features, that's where Hyper-V servers are a great fit. And we see people deploying it into their branch offices, their remote sites. We see a lot of people starting to use it for Linux, and we'll talk about that a bit later. But free hypervisor with some of the free distributions of Linux and still retaining the resiliency through HA, great solution. Now, interestingly, when VMware launched 5.1, this number was around about 3,000 VMs for the cluster size, and it suddenly jumped to 4,000, which coincidentally matched our 4,000 cluster size for Hyper-V at release candidate. And they assumed that that's what we would finally, when we got to RTM, that would be our final number, 4,000 VMs on a 64-node cluster. But no, we tested right up until RTM, and then we announced right at RTM time that it was going to be 8,000 VMs on that size cluster. So it's kind of a little tick mark there on the Hyper-V side. But you know, both sides, both vSphere and Hyper-V, provide more than enough scale for most organizations. But like I said before, there are certain organizations now that are starting to deploy big, big clusters, and the 32 nodes wasn't quite enough for them. So we're starting to see it now. Anyway, what are we doing around storage? So I want to introduce and talk about a couple of the features that we're bringing to market in 2012 and 2012 R2, and then we'll compare them with what's in vSphere. And in many cases, they're either in vSphere or maybe they're only in Hyper-V. So we'll see. So we introduced Virtual Fiber Channel. This allows you to connect a running virtual machine or a VM on a Hyper-V host directly through to your Fiber Channel SAN. No need to worry about pass-through disks or RDMs. You just connect that Virtual Fiber Channel adapter from the VM through to the Fiber Channel storage, protecting that investment and allowing you to present LUNs from your storage array through to your virtual machines directly. Get a more native level of performance, and you still get the flexibility to move those virtual machines around using live migration. And that's a feature that was new in 2012, but it's been in vSphere for a while. It's been in there a while, so you've been able to utilize that capability to present that fiber channel storage through. So that was new in Hyper-V, so an element of catch-up there. But it's now providing more flexibility for scenarios like guest clustering, which we'll touch on a bit later. But Jeff Woolsey touched on this in his in our Windows Server session earlier on. The support for this new advanced format drives, these 4K sector disks. So Hyper-V supports placing our virtual disks, our VHDX files, on top of these new 4K disks. Now, many of you may not have these 4K disks. They may still be new to a lot of organizations, and they may only come around as and when you refresh your storage infrastructure. But it's something to be aware of. Hyper-V supports them today. So for increased capacity, better alignment and reliability, putting our Hyper-V virtual disks on those new 4K disks could be very advantageous. But here's the big one. A lot of organizations we talked to when we were bringing to market 2012 fed back around 2008 R2 to say, the virtual disk is great, performance is fine, does the job, but I'm regularly running into capacity issues. I need more than 2 terabytes. And the answer at the time was, well, you need to attach more virtual disks and have lots of 2 terabyte disks attached to your VM. Well, that's gone away now. So if you want to create huge, massive disks on Hyper-V in 2012, you can do it. Because 2012 now supports a new VHDX file format that brings enhanced alignment, increased capacity, up to 64 terabytes. So that's 32 times bigger than our previous virtual disk size and 32 times bigger than VMware's virtual disk size. So giving you lots of flexibility, and that's per disk. Don't forget, Hyper-V virtual machines support around about 250, 255 virtual disks per VM. So that's about 16 petabytes of storage per VM. You're not going to hit that limit, or it's very unlikely. But we've done some clever stuff in 2012 R2 to enhance the administration around virtual disks. Because it's great having huge disks, but what if you create one initially that's very small and you need to grow it on the fly? My answer today, with currently shipping products, is you'd need to power down that VM and resize the disk offline. My answer in the future, or if you download the preview, which I hope you are going to do, then we can do it on the fly. So we can increase the size of the virtual disk and then increase the volume inside the VM whilst the VM's running. And in addition, we can shrink it back down. VMware only offers today the online resize of an increased disk, whereas we're offering both resize both ways. So pretty powerful, flexible as well. But what else? What else around storage? We frequently get asked, can I run Hyper-V from a USB disk or an SD card or some kind of flash media inside a diskless server, essentially? And the answer is you can. You work with your OEM, and it's Hyper-V server only that can run on a USB disk, not an SD card. Okay? So you would work with your OEM from that perspective to deliver that. That's different from vSphere, which offers that little bit more flexibility if you're looking to deploy a diskless server, by providing options to deploy on USB and or SD card. So you've got a little bit more flexibility on the vSphere hypervisor side, if you want to go that way. But note, like I said, on Hyper-V, it has to be Hyper-V server, not the full Windows server with Hyper-V. Reason being, whilst the Hyper-V team will support Hyper-V on a USB stick, the rest of the Windows org, Active Directory, remote desktop services, all of those other teams that support the rest of Windows Server won't. So they support only full-fat Windows. If you want to run it on USB, you'd have to use Hyper-V Server. We introduced a technology in 2012 to help you reduce the burden on your hosts from a storage perspective. Think about some of the tasks you regularly perform in your environment with Hyper-V or with vSphere. You may be creating new VMs from templates. You may be doing storage migrations in a VMware world, a storage vMotion. Those can be quite intense on the host. Because typically, if you've not got an ODX-capable SAN, for instance, that process of moving a virtual disk from LUN number 1 on the SAN to LUN number 2 typically goes via the host and uses valuable CPU and network resources and memory to actually transfer from the place on the SAN to another place on the same SAN. It doesn't make perfect sense. It's why not get the SAN to do that work? Because it knows exactly where the blocks are going to and from, and it can do it like that. That's where ODX comes in, or offloaded data transfer. Now, VMware have had that feature since around vSphere 4.1, called VAAI, the vSphere vStorage API for array integration. So offloading that task, that storage vMotion or that clone, whatever it may be, to the SAN and reduce the burden on the hosts. Hyper-V offers that same capability, known as ODX, in the box. There's no specific SKU requirement, though. So it's in every edition of Hyper-V. So if I've got a SAN that's got the latest firmware, no doubt. You probably will need an update to your firmware if you've not updated it in a while to unlock the SAN side of ODX. But aside from that, I don't need to do anything on my Hyper-V hosts. ODX is enabled by default, and it's in every edition. So you can take advantage of that to increase the performance around those storage-intensive tasks. But this is where it starts to get interesting and where we start to divert slightly away from Hyper-V specifically. Because we've done an incredible amount of work in 2012 to enhance and reduce the cost of storage. So instead of utilizing expensive SAN technology, which lights up with features like ODX, we can utilize lower cost JBOD, direct attached storage, and transform that with our storage virtualization technology, if you will, storage spaces, where we create pools of physical disks, and then we slice them into spaces. So kind of like you would with a SAN. Your SAN would have an aggregate of disks in a big pool, and you would slice it into LUNs, and you would present those LUNs through to hosts or file servers or whatever. Same kind of thing with spaces. You create your pool, you slice it into spaces. They can be thin provisioned, you can have deduplication, and you present them through for use by Hyper-V to store VMs or file servers to store application data, whatever it may be. And we saw in the keynote, and we've seen in, I'm sure, many of the other sessions you've been to, we've introduced in 2012 R2 tiering for those spaces. So you can see enhanced performance, moving the hot blocks to different locations within the space to drive higher performance. So when we start to compare with vSphere, you'll see that the vSphere hypervisor itself is lacking a couple of the capabilities. As I said, that offload to the SAN, it's only in some of those higher-end editions of vSphere. Enterprise, Enterprise Plus. When you start to think about some of the other fiber channel, yep, that's across the board. Multipathing is an interesting one because it's something that's so important for those of you who utilize SANs, iSCSI or fiber channel. Multipathing gives you that resiliency, it increases performance. It's an important part of any SAN configuration. With Microsoft, third-party multipathing, i.e. using the storage vendor's specific configuration optimizations, is included. Either you can use our inbox framework or you can layer your storage vendor's enhancements on top. Doesn't matter which edition of Hyper-V, there's no extra licensing consideration to do that. You obtain the files from your storage vendor and on they go, and that path between host and SAN is optimized. With VMware, however, you can't use those third-party multipathing enhancements unless you start to go to some of the higher SKUs. So with the lower-end editions, the cheaper editions, you're limited. You can use the in-box multipathing just like you can on Hyper-V, but that might not be the optimal configuration for your specific SAN. It's much more optimized when you are using the device-specific modules from your specific hardware vendor. We talked a bit about disk size, so the support for 64 terabyte disk versus 2. And the online virtual disk resize, anything that's in yellow is new in R2. Anything that's in white is in 2012. So if you're trying to build up an idea of what exists today and what's futures, that's where it is. So you'll see storage pooling is in 2012, but tiered comes in 2012 R2. Now VMware on the vSphere hypervisor and vSphere Enterprise Plus, they don't do storage pooling in the box. However, VMware, more so than any other organization I can think of, are working in storage, apart from Microsoft obviously, are working incredibly hard in storage. They acquired Versto, which offers them a new angle on I/O in that virtualized environment, incredibly useful for things like VDI. But they're also working on things like vVols and vDistributed storage. So we're both working towards trying to transform lower cost commodity storage into something that's resilient and something that's high performance for your workloads to help you drive down those costs. So it's interesting that both vendors are working along that path. Slightly different approaches, and we've played our cards both in 2012 and in 2012 R2 around our spaces strategy and the scale-out file server. So it'll be interesting to see what gets announced at VMworld, no doubt, in a couple of months. Either way, both solutions offering a lot of storage capability, but a couple of advantages on the Hyper-V side. But then we think about how we manage our resources effectively. Dynamic memory, as I said, was introduced in 2008 R2 SP1. And up until that point, every Hyper-V VM you created, static amounts of memory. I want this virtual machine to have 8 gig of RAM, even if it sits at 2 gig for most of its life. It's a bit of a waste of the remaining 6 gig. Dynamic memory comes along, and that allows us now in 2012 to specify a granular startup figure. So I would like this VM to start with 2 gig of RAM. A minimum, I would like this VM to have a minimum of 1 gig of RAM. And a maximum, I would like this VM to have a max of 8. So it would start with 2, it would get started, get its services up and running, and if it got quiet, it would drop to 1, and if it got busy, it would rise to a maximum of 8. But on top of that, if it was constantly at the 8 gig, the maximum, and it was really struggling, we could introduce a new feature in 2012, or we did introduce, that allows you to, as the administrator, to increase that maximum. So it's effectively hot add RAM to the running VM. So we introduced a lot more flexibility in 2012, ensuring that the feature was not only delivering great performance, but it still gave you the administrative control that you needed to adjust on the fly. But that's just one technique. One technique within Hyper-V. There is another, smart paging, which will utilize some of the local systems disk, could be spinning, could be SSD, SSD is probably preferable, to actually handle some of the paging in the event of a failover perhaps, lots of VMs failing over onto a new host, need to get those VMs started, there's maybe not quite enough RAM to go around, so we need to utilize some of that paging space on the local disk to get those VMs started. So dynamic memory and smart paging. Smart paging was new in 2012. But VMware have a handful of techniques. You think about the compression and the swapping. Swapping similar in some ways to the smart paging I talked about there. Swapping effectively, utilizing disk to simulate RAM to get VMs or keep VMs up and running. Compression, compressing some of the memory inside the virtual machine, if appropriate, to free up RAM. Think about transparent page sharing. If you've got that on your physical system, transparent page sharing is like a deduplication for memory, where vSphere and the ESXi host is monitoring the usage of memory, monitoring the pages within memory for all of the virtual machines, comparing them, and then deduplicating them where it can. Now, on newer systems that have large page tables enabled by default, which is the vast majority of newer systems, it's a lot harder for the ESXi host to deduplicate those 2 megabyte pages, as opposed to the 4K pages it would have done with small page tables. And in that respect, it's harder for the host to deduplicate, but it will still deduplicate them if the host is under extreme memory pressure. Hyper-V doesn't have any form of transparent page sharing. It will use the ballooning. It uses the dynamic memory that is that balloon driver within the VM to push that memory out. Similar, at least apples to apples, it's as close as you'll get to comparing with VMware memory over commit. But does that give Hyper-V a disadvantage having less techniques? No. Hyper-V still offers that great level of density and the granular control to really help you get great density on those systems, similar to what you would get with vSphere. But where vSphere does have a slight advantage is where it tracks resources. It tracks what's going on inside your virtual machines. If you use vCenter, which I'm sure many of you have or do use, the wealth of information that vCenter gets about the VMs, the hosts, and presents them through nice real-time graphs and performance charts is very, very granular. Hyper-V's resource metering takes a historical look on an average basis on CPU, memory, disk, network for virtual machines. And you collect that through PowerShell, and you can pump that into other systems, charts, dashboards, whatever they may be. It's not as, let's say, mature as VMware's collection mechanisms within vSphere and vCenter, and that can be piped up into vCenter Chargeback, which wraps billing around that. So VMware have a slight advantage there, but it does allow me to collect resources and meters within the Windows Server OS. If I had a tool like Operations Manager within System Center, then I could pull a lot of that information from just using Ops Manager. So whether I use that feature or not, it would depend on your environment. But then we've done some significant work, both in 2012 and going on to 2012 R2, in helping you control the quality that you deliver to your tenants, your customers, your internal business users. Firstly, network QoS, enabling me to specify a minimum and a maximum bandwidth allowance, either explicitly, so the maximum is 500 meg, minimum is 100, or on a weightings basis, so this VM is weighting of 60, this VM 40. Either way, that network QoS allows us to control the quality and the bandwidth available to a certain VM, and it's on a VNIC by VNIC basis. So I can configure that pretty granularly through the GUI or through PowerShell to provide a level of control on a network basis. And then in 2012 R2, we're introducing storage quas. So this enables me to say, okay, for this virtual disk, so it's a disk by disk basis, I want to put, for instance, a maximum cap. So if you're in an environment where you're sharing an infrastructure and one VM suddenly ramps up an iometer test and just forgets about it and leaves it running all the time, your I/O to your SAN or your storage repository is going to be hammered. But if we click that virtual disk and say, whoa, 100 meg is the max, apply, it will drop right down. So we're introducing those levels of control. Networking was in 2012, storage quals in 2012 R2. So giving you those granular pieces of control. However, VMware in vSphere Enterprise Plus, that's offered the network and storage I/O control, as it's known in the vSphere world, for a couple of releases now, and it's a pretty granular solution. Gives you nice information back in vCenter about what's going on and provides a lot of control over those different configurations. And we've mentioned the resource metering as well, offering that little bit more granularity. But it's all in the box in Hyper-V. It doesn't exist in that vSphere hypervisor, you'll see. That quas, that I/O control, is only reserved for the very top edition. So it's not even in the Enterprise edition. But that was a bit about security and some of the that was a bit about scalability and some of the features that can help drive performance. Now, I'd love to be stood on stage and have some side-by-side graphs that say Hyper-V performance is this, vSphere performance is that. But unfortunately, the EULA prevents us from doing many of those tests. But in the future, we'll see if that changes. We'll see if we start to publish comparative benchmarks versus vSphere. But we'll see on that one. At least for today, all we can do with our performance is put a stake in the ground and showcase the kind of performance we can drive with Exchange on Hyper-V, SQL, SharePoint, SAP, as you've seen as well. So we're doing a lot of work just to prove our own performance versus comparisons. Anyway, moving on to security. The fundamental building block for isolation within the Hyper-V world is the switch, the networking switch. In 2012, it went through a dramatic change. If you used it in 2008 R2, or you've heard about it in 2008 R2, it was a relatively simple network switch. Connect VMs to the physical NIC, out to the LAN. VMs communicate, can use VLANs, all of that cool stuff. But in 2012, it just got blown completely open. Completely open and extensible for partners to plug in. But not only can partners plug in, we can also provide a number of granular capabilities in the box, protecting against certain pieces of attack, certain types of attacks. ARP and neighbor discovery poisoning, DHCP guard protection, router guard protection. We can trunk lots of VLANs to individual virtual NICs within VMs. PVLANs is exposed through this new granular networking switch. So I can have VLANs within VLANs if I do still want to utilize that approach. The network traffic monitoring is in the box, so I can mirror traffic to another virtual machine for analysis, for instance. So lots of granular capabilities coming into Hyper-V in the network switch. But as I said, it's extensible. It's extensible from partners at multiple different levels. So for instance, I could talk to Cisco and utilize their Cisco Nexus 1000V that would allow them, and it's available for Hyper-V, newly released, and that would allow me to integrate with my rest of my Cisco networking infrastructure in the same way that it would for vSphere, where the Nexus 1000V has been out for ages. So that would effectively provide that functionality for Cisco users in the Hyper-V world and give great visibility into the virtual and the physical network environment. But then it's other partners that are starting to plug in. Smaller partners like Five9, who produce a security manager product for agentless antivirus for Hyper-V VMs and a virtual firewall product, all within that security manager product itself. And they plug in at a slightly different level of the Hyper-V virtual switch. So that's important. This virtual switch isn't just one extension at a time. Because it's layered, partners can plug in at different layers that's appropriate for them. And it's all standardized with Windows APIs and interfaces that partners and customers can write their own to map to their existing and their specific needs within their environments. Inmon, with their S-Flow product for monitoring, they would plug in at a slightly different level of the Hyper-V switch. But you can use them together or separately, it's up to you. But this is the power of the extensible switch. And this is very different from the VMware vSwitch, whether it's the standard vSwitch, which is closed. You can't really modify it beyond the options that it gives you within vCenter. I can't plug a partner product in. And you'll say, whoa, hang on. The Cisco Nexus 1000V, that's a partner product. That plugs in. The IBM equivalent, that plugs in. Well, no, that replaces. That's the options you have. The vSwitch is closed. Use the standard vSwitch, use the distributed switch, or you use the Cisco or the IBM switch. With the Microsoft option, you've got all of those extensions you can plug in at different points. And when we start to compare, the vSphere hypervisor itself doesn't have any of those granular capabilities, those granular networking capabilities that organizations are looking for to stay secure and isolated. But then when you look at some of the VMware sides in the higher end editions, like the vSphere 5.1 Enterprise Plus, some of those more advanced, more granular security protection mechanisms are provided either by a partner, like Cisco, or in the vCloud networking and security product, which is an add-on to vSphere. So core in the box in vSphere, it's missing a few of the bits, but actually when you start to bolt on some of the other technologies around vSphere, like the Cisco Nexus or the vCloud networking and security product, you would have those similar capabilities to what's offered in the box by Hyper-V. But don't forget, all of those are in the box in the free edition of Hyper-V. It's not just in the data center or just in standard, it's in every edition. So, sticking with networking briefly, there's been an incredible amount of work done, both in 2012 and now in R2, to drive higher performance for networking. And vSphere and Hyper-V share some similarities here, but Hyper-V really pushes through with some unique capabilities. Dynamic VMQ helps to balance the processing of traffic, network traffic, from the virtual machines across the CPUs in the system. IPsec, if anyone's using that, we do extensively in Microsoft. IPsec, the encryption and decryption of traffic, can generate quite a burden on the CPU. If you've got a load of servers running on a single physical server, all of them are using IPsec, that could be quite a lot of CPU cycles wasted just through the encryption and decryption. Well, we can offload that to the physical NICs if they've got this IPsec task offload capability. And that's something that's a feature of Hyper-V. But new in 2012 R2 is something called virtual receive side scaling. So inside the VM, for VMs that are heavy on the network traffic, they can handle that processing of that traffic more effectively inside the VM using VRSS across the virtual machines processors that are available to it. So we can balance the traffic at the VM level. We can balance the traffic processing at the host level as well. So we're very, very flexible but powerful in terms of how we deliver that. And finally, a big one. To deliver those highest levels of performance, you want to give the most native experience. And to do that, we need to give as close to physical performance as we can. And one way to do that is to present physical devices through to the VMs. Now, VMware has an approach to this called Direct Path I/O, which can present PCI devices or certain PCI devices from the ESXi host through to a VM. Problem with Direct Path I/O is it locks that VM to that host. So you lose some of the flexibility for things like vMotion. With SRIOV in Hyper-V, we introduced this first in 2012, and it enables you to not map the actual physical device through on a one-to-one basis to the VM, but instead, the SRIOV physical NIC has what's known as virtual functions. So we map a virtual function from that physical NIC through to the VM's NIC instead. And it gets a more direct path through to the physical network adapter, increased performance, reduce CPU utilization on the host as well. The beauty of the Hyper-V configuration with SRIOV is it fully supports live migration. So we can live migrate SRIOV-enabled VMs from A to B, even though you think, well, it's using the physical NIC on this host. If I move it, what's going to happen? Well, when we're moving the virtual machine, we quickly remove the SRIOV NIC and fall back to a software path. So the connectivity is still there, and we move the VM over to the new host. And when it gets to that new host, if it's got SRIOV physical NICs, we'll pop a virtual function back into the VM, and the VM will use the SRIOV path. If it hasn't got an SRIOV physical NIC, we'll just carry on using the software stack. So you can just migrate those VMs around flexibly without having to worry if that target host is going to have an SRIOV NIC or not. So we're doing some clever stuff. As I said, this diagram kind of explains it. Normal operation, traffic going down the Hyper-V switch, down the normal stack. We turn on SRIOV for a VM, it pops the virtual function inside the VM, and the traffic runs through that particular path, which is enhanced, but you lose some of the Hyper-V extensible switch capabilities because we're bypassing it completely. So your switch extensions are no longer applicable there. But then we change direction. Let's focus on a slightly different type of security. If you've got physical servers residing in less physically secure locations, or you've got a compliancy requirement for encryption, that can be quite difficult in a vSphere world. Certainly there's no capabilities in the box that offer encryption. But with Hyper-V, with BitLocker in Windows Server, that enables you to encrypt those drives where those virtual disks reside. Whether that's on the Hyper-V host itself, in local storage, we'll encrypt it. In this case, the VM's virtual disk is on the F drive, which we've encrypted with BitLocker. You will have a slight performance hit. That's to be expected, but it is only relatively minimal. But that's going to give you that compliancy if you've got a requirement for that. But you think, okay, BitLocker, I've seen this on laptops and desktops. When people open their PC, they have to put a pin in or have to have a USB stick in the machine. This is a lights-out data center. I can't do that. Well, that's where the network unlock and the AD integration come in. So we can securely boot those machines without having to actually visit them. So don't worry from that perspective. But if you've got LUNs presented to from the SAN, so traditional LUN, directly to a host, given a drive letter and a volume, disks on there, let's BitLocker it. We can encrypt that, no problem. Cluster shared volumes, yeah, we can encrypt those as well now in 2012. And if you're running virtual disks on a Windows Server file server, we can encrypt at the file server level. Okay, so the location of those virtual disks is encrypted. And all of that is in the box. So it enables you to meet that compliancy need, and if you've got a requirement to have encryption perhaps in a less physically secure location, you're good to go. Now, some of those capabilities, let's just explore and compare and contrast. With the dynamic VM queue, VMware do have a capability called the equivalent of VMQ. Not dynamic, but VMQ. They call it NetQ. And this effectively handles the processing of the network traffic utilizing the CPU in the system. But it's not dynamic, so it's not balancing across multiple CPUs in the host as effectively as what Hyper-V would deliver. There's no support for IPsec task offload, but it does support the VRSS. And that was in vSphere 5.1, but you need to use the VMX Net 3 network adapter in the vSphere world if you want to unlock that inside the VM. The other types of vSphere NIC, they don't support that. SRIOV with live migration, no. On the vSphere side, no. You cannot vMotion a VM in 5.1, and that's when SRIOV was introduced. I cannot vMotion a VM from A to B if I've got SRIOV enabled. So you make a choice. You either choose the performance with SRIOV and you leave the VM where it is, or you choose the regular performance, which is great, but you can then vMotion it around. So you've got that flexibility. With Hyper-V, you've got both, agility and performance. And as we said, there's no encryption in the box for vSphere. But with Hyper-V, you've got it as part of Windows Server. It's even in the free Hyper-V Server, if you were thinking, is that just a Windows Server thing? It's in Hyper-V Server as well. So, when we think about flexibility, we've alluded to some of the flexibility, live migration, storage migration already. But flexibility isn't just moving VMs around. It's also having flexibility to choose which operating systems you deploy. I'd love to sit here and everyone say, we just deploy Windows. But that's not the reality in a lot of organizations. We deploy other things. And in 2012, we did a lot of work to enhance our story around supporting Linux. Working with the Linux community and the commercial vendors associated, the likes of Red Hat, SUSE, and so on, to help drive, A, better driver quality, better Hyper-V driver quality inside the virtualized Linux distributions. And now you'll find that we've worked that closely that the Hyper-V drivers are actually right in the software stack of the Linux kernel. So any distributions built from those kernels have Hyper-V drivers within them straight away. So no tools to install, no integration services to install. If I go and download the latest distribution of Ubuntu, for instance, and I put it on Hyper-V, it's optimized by default. If I go into the equivalent of Device Manager in the Linux OS, I don't see third-party devices in that. I see standard devices that are part of the kernel that have been approved and have been delivered in cooperation. So we're really driving better experiences for Linux on Hyper-V. And the thing always comes up, well, is it supported? Can I ring Microsoft if there's an issue? Absolutely. For Red Hat, SUSE, OpenSUSE, CentOS, and Ubuntu, you can ring Microsoft. We'll support you. We'll take that call. But if it's one of the other distributions, maybe a completely different distribution that you've downloaded, it will run great on Hyper-V, but the support wouldn't be in the same way. However, when we look at some of the features we're trying to enable, especially going forward in 2012 R2, we're trying to bring Linux on more or less parity, make it a first-class citizen with what we deliver for Windows guests. So things like full dynamic memory support for Linux. This will be introduced in R2. So today, as it stands, we don't support dynamic memory for Linux guests. But in 2012 R2, you'll find that that's fully supported. Live backup. Backup for Linux can be quite painful naturally, physical or virtual. But if you're running it in a Hyper-V virtual machine, we've done some clever stuff, both the Hyper-V layer and inside the Linux guest through our driver integration, to really streamline the way we snapshot and take those live backups with no downtime of Linux guests. In many cases, you're actually better off from a backup perspective with it running on Hyper-V and backing it up through Hyper-V's tools and tools that call Hyper-V's VSS writer than you are having it in the physical world. You can offer that more flexible and more granular backup capability. There's better support for things like virtual SCSI, hot add and resize of virtual disks, and the multiprocessor support. That's actually there today. All of the Linux distributions that are supported, you'll see them on the TechNet supported list. They support 64 virtual procs, which is ironic because some of the Windows distributions we don't support with 64 virtual procs, but that's another story. Anyway, what else was introduced? Live cloning. Very, very useful from an administrator perspective, and something that customers have asked us for quite a while, probably due to the fact that they've had that in vSphere for a little while, the ability to live clone a virtual machine that's running. Now, you need vCenter for this on the VMware side, but with Hyper-V, I can do it straight from within Hyper-V Manager. And this is actually we call it live cloning, but it's actually a live export. So it will export that running VM to a new VM that's in an off state, and you can go ahead and you can start that up and reconfigure it as necessary. Really useful for troubleshooting, triaging bugs, whatever it may be. So we click, yeah, I want to do the live export. Hyper-V performs a point-in-time snap, exports all of that, does the necessary merging, and not only can I can do a live export from a running VM with just a single virtual disk, but I can also do a live export from a virtual machine that's got snapshots. So if you've got a chain of snapshots for this VM and you think, I would like to live export from last Tuesday's snapshot, I can do that. And it will create a fully fledged virtual machine from one of the existing snapshots. And you could give that to your dev team and they could work on it, for instance. So very, very flexible. But what the result is, you've got a new powered off virtual machine that you would import, you would finalize the configuration, you would start it up. But don't forget, that VM is identical to that other VM. It's not doing any magic around sysprep or preparing it in any special way. It is identical. So if you put it on the network and you start it up, you've got two machines identically configured there. So, common sense will prevail there. But with VMM, the process is very raw in Hyper-V. Right-click VM, export. Where do you want to put the files? Go. With VMM, it's more of a wizard-driven process to say, okay, you want to export this VM or clone this VM, that's fine. Do you want to clone it to the library? Which host would you like to place it on? So you can be a bit more flexible about the placement of that. As I said, VMware have had that flexibility to live clone for a while, but now it's new in Windows Server 2012 R2. So this isn't in 2012 as it stands today. But when 2012 did release, there was a huge amount of improvement around migration. Live migration's been in since 2008 R2, but as we continually got dinged by VMware, we can move more virtual machines simultaneously than you. It's like, okay, yes, we can move one VM at a time between two hosts, maximum of 8 at a time on a 16-node cluster. Fine for some people, not enough for others. Imagine the scenario where you've got a physical host with lots of VMs and you need to put maintenance mode in place. VMs need to evacuate. With Hyper-V, one at a time. One VM. When the next one finishes, it'll start, next VM, next VM, next VM. In 2012, simultaneous migrations, unrestricted. You specify your maximum number. That's a different approach to vSphere, where they say 4 migrations on gigabit, 8 maximum on 10 gig. We let you decide. If you want to harness more migrations simultaneously, that's fine. And we feel that you can increase the number of your migrations going forward in R2 especially, because we introduce things like compression, where we're compressing the memory for the virtual machine before we send it across during a live migration, which can cut the live migration time in half. vSphere has no similar capability. But in 2012 R2 as well, support for RDMA as those network adapters used for your live migration network, which means I can transfer that traffic drastically faster between those two hosts, which means I can migrate my VMs incredibly quickly. Now, this isn't supported today, or at least been last checked with VMware at this stage. They support RDMA NICs, but not necessarily for vMotion at this time. We introduced live storage migration, giving us a big tick in the box versus a vSphere storage vMotion. Now, storage vMotion on the VMware side, initially when it first released, it was great. It allowed you to move virtual disks around your SAN for maintenance, capacity reasons, whatever. And then it went through an evolution and improved considerably with a mirroring mode, where the I/O is mirrored to the target and the source virtual disk as the VM is migrating. So a more efficient way of moving that virtual disk around. And the Hyper-V approach is very, very similar to that approach. But it's been built in the box. It's in every edition of Hyper-V. But then finally, the big one. The big one where we take the best of this, moving the disk, the best of this, moving the running state of the VM, combine it together, and just allow you to throw VMs around your network. All you need is an Ethernet cable. Don't need shared storage. Just that Ethernet connection connecting those hosts. So if you can see from host A to host B, you can move that virtual machine. Flexibly, easy to move, and that was a first for the industry. At the time, vSphere 5.1 wasn't available, but that did introduce that capability in for vSphere as well. But interestingly enough, you can only use that feature in vSphere with the web client of vSphere. You can't use it with the full vCenter client, which many of you, I'm sure, are still using. But this is important, and this was the live migration upgrades is a question we've had certainly as we increase the cadence that we release Hyper-V and on Windows Server 2012. You'll find that more and more customers, certainly from a VMware world, are used to being able to move VMs onto fewer hosts, do an in-place upgrade, vMotion back, upgrade the next host, very much like the graphic depicted there. And that's something that now in 2012 R2 is going to be introduced. So for customers who're currently on 2012 and want to move to 2012 R2, they're going to be able to migrate VMs directly to 2012 R2 from 2012, meaning a little bit more flexibility, streamlined upgrade process, and it can be automated with PowerShell. And if your VMs are on SMB storage, because you can present SMB storage to 2012 hosts and 2012 R2 hosts at the same time, what you'll find is that the VM literally only needs to move state to migrate between 2012 and R2. It doesn't need to move the disk. So even more speed at which you can upgrade to a newer version. So very, very flexible. It is one way only. So if you're thinking, could I go back to 2012 from 2012 R2? No, that's not possible. It's only one way. Now, as I said, vSphere's had that migration capability for a while. And that's a big game changer for Hyper-V, to be able to flexibly move forward in that way. But the other big game changer within this flexibility discussion we're having is around networking. Hyper-V in 2012 introduced network virtualization, which is fundamentally going to change the way we provision networks in our environment. Instead of needing to provision VLANs and configure every single port and switch within the network, manually potentially, which is very time consuming, we're moving towards a way of delivering that through software. And at the same time, removing the scalability limits for VLANs. So Hyper-V network virtualization supports up to 16 million networks, which is phenomenally scalable. But it also allows us to move virtual machines around the network completely flexibly, providing our physical hosts can see each other. Now, I wanted to spend a minute or two just explaining some of these key concepts for network virtualization, because it may be the first time some of you have seen it. We have this concept of what we call a provider address. Think of it as an IP address that the physical host has. Now, a physical host, these provider addresses help to identify where these physical hosts are. And it helps us to identify which VMs are running on which physical hosts. And on top of these physical hosts with these provider addresses, we create VM networks. In this case, we've got a blue network and a red network. We create these in System Center, Virtual Machine Manager. VMM is incredibly important to network virtualization. In fact, so much so that you can't do it at scale in any way without VMM. It's imperative. But that allows us to build the VM networks and deploy VMs into these networks. Notice these VMs have an IP address of their own, as you'd expect, and that is the customer address, the guest OS IP. And you'll see that the red network VMs and the blue network VMs have got identical IP addresses. Yet because they're isolated in these virtualized networks, they don't conflict. No VLANs, they're running on a simplified physical network, but they're isolated. But this is where VMM provides an important piece of information. It maintains this policy table that contains information like the network, the virtual subnet ID, so it's the blue network and it has an ID that's attached to that. The provider address where the virtual machine is running. The customer address, the virtual machine's IP. So if I need to know at any time where 10.10.10.10 blue is, VMM will tell me it's on this particular host and it's in this particular virtual subnet. So we've got a lot of information in VMM. And VMM will place snippets of this table on each of the Hyper-V hosts. So VMM is the central source, but each Hyper-V host will have a little bit of the table that it needs. And if the information that the Hyper-V host needs isn't in its table, it will talk to VMM and it will update its table appropriately. Now you'll notice here with the stars that there is a VM, 10.10.10.12 blue and 10.10.10.12 red, that's running on the same physical host, 192.168.2.12, and it's got the same customer address, the same guest OS IP. Doesn't matter, because network virtualization isolates them all. And it does that through NVGRE. So it does that through a standard, through tunneling. Now this is a different approach to what VMware is taking. VMware with VXLAN is taking a different approach to NVGRE. They're achieving the same goal, removing those VLAN restrictions to 16 million networks, but they do it in a slightly different way. NVGRE is Microsoft's approach. VXLAN is the way that VMware have gone, at least partially, and I'll explain that in a minute. So we can now move VMs flexibly between physical hosts that are on completely different subnets because those VMs, they're on the same virtual network. And that virtual network stretches across all of the hosts. It's completely agnostic. We can flexibly move those virtual machines around anywhere. But we encapsulate the data that these VMs want to send to one another because that data, if 10.10.10.10 wants to talk to 10.10.10.11, to get its packets there, it needs to send them over the physical network to get there. So we need to encapsulate the VM's packets and information in something that's going to traverse the physical network. And that's what the GRE is, encapsulating that VM packet to send it across the physical network. Think about when you send a letter, if anyone does still send letters. You write the letter, you put it in an envelope, and you post it. The envelope is that encapsulation. And when the receiver receives that letter, they open it and they remove the letter, the packet. So we've encapsulated it to get it across the physical network. So, sad analogy, but it works for me. But that's how NVGRE works. And it's a standard not just backed by Microsoft, Intel, Arista, HP, Dell, Emulex, big vendors supporting this going forward. But how does that packet flow? How does this work fundamentally? Well, Blue 1 wants to talk to Blue 2. So it says, okay, I'm going to send you a packet. And remember, the VM has no idea about this network virtualization. Just in the same way it doesn't know it's a virtual machine. It just thinks, oh, I'm having a great time, I can send network traffic, everything's great. So it says first, okay, I need to figure out where 10.10.10.11, just in the same way it would in the physical world. So it sends out an ARP to locate that target server. But the Hyper-V switch grabs it and says, whoa, whoa, whoa. This isn't going out onto the network. We're not doing a broadcast here. I'm going to help you get this information. So firstly, the Hyper-V switch broadcasts that ARP on the local virtual subnet. So it sees if any VMs on that host are within the blue subnet, the blue network, and if they are, is it 10.10.10.11? In this case, it's not. So it comes back no result. So the Hyper-V switch then broadcasts the ARP to the rest of the network, or at least it thinks it does. Because it's at that point, network virtualization grabs it and says, okay, here we go. I know you want to send a packet somewhere. I need to figure out where this 10.10.10.11 is. So I'm going to check my policy table that VMM has provided me. And I know from that, I know where the VM is, I know its virtual MAC address, so it provides that back to the Hyper-V VM, into the VM. So now the VM has got all the information it needs to send its packet to Blue 2. So it constructs its packet. And the packet looks like that. Remember, the VM has no idea about this network virtualization. It just constructs a normal packet like it would in the physical world. Hyper-V, the virtual switch, attaches the vSID. This identifies which virtual network, the blue network, that it needs to target when it gets to the destination host. So it wrappers it with an extra bit of information on the header. The network virtualization filter checks if it's allowed to send to that VM, and if it is, it sends it across the physical network. Notice there's no IP multicast going on here, which is one significant difference with VXLAN with VMware. It's a significant difference. We push it across the physical network. Notice we're going to a different subnet, 2.10, 5.12, doesn't matter. As long as these two can communicate, that's fine. And when it gets there, the reverse process happens. So we strip off the GRE, the extra physical bits we needed to get from A to B. We strip off the virtual subnet ID because we now know we're looking for a blue VM in the blue network, and we send the packet through. That's how network virtualization sends its traffic between VMs across hosts. Very, very flexible, easy to deploy through VMM, and enables us to just transform the way we deploy networks. No need for VLANs. We're segregating our virtual workloads using this network virtualization. But we need to be able to communicate out. We need to be able to communicate from those virtual machines in those VM networks to perhaps laptops or desktops that are on the physical network. Or maybe we're a service provider where we need to communicate from blue Contoso across the internet into the service provider's infrastructure and communicate with our blue VMs that are running in their multi-tenanted environment. If that's the case, then we need some kind of bridge to translate that traffic across a physical network. And in that respect, we use what's called the gateway. And the multi-tenanted, scalable, production-ready gateway ships as part of Windows Server 2012 R2 in the box. Now, what if you're saying, well, what about with 2012? If I wanted to deploy this in production today, what would I do for 2012 if this gateway is only 2012 R2? Well, in 2012, we have a lot of partner solutions that have come to market that would enable you to provide the same functionality. Iron Networks is a good example of one. That would provide a gateway for 2012 network virtualization, but in the box in 2012 R2. Now, if we compare with VMware, let's go back to that live migration. There's no compression, no RDMA support on the vSphere side. But as of today, there isn't with Hyper-V. It's only in 2012 R2. So that's something that's coming. If you look at the free vSphere hypervisor, when it comes to migrations, because you can't build clusters, you've got no migration capability. You have to be running an edition of vSphere to take advantage of that. We support unlimited migrations, but you would specify the max number based on your workloads. You wouldn't just put 100 migrations in just because you can, because that could take a long time if your pipe of network is only so big. So your workloads could, if they're migrating for a long time, that's going to impact the workload slightly as it's migrating. So something to be aware of. But live storage migrations in there, shared nothing is in there. One question we get quite a lot, what is your equivalent to DRS? Because we use DRS all the time, it moves workloads around, our clusters, we don't need to do anything, it just balances. What is your equivalent? That's not in Hyper-V. Live migration to move the VMs is there, but the intelligence to move it automatically isn't. But VMM provides that, Virtual Machine Manager. So running VMM with Hyper-V is very, very important, not only for network virtualization, but also for this kind of capability as well. So both a load balancing, moving workloads around with dynamic optimization, and power management, shutting down physical servers, moving VMs onto fewer hosts to save power. That's all in the box, but provided by VMM. Okay? So, wrapping up, comparison. VM cloning, yeah, we touched a bit on that before as well. They're new in R2. Network virtualization was introduced in 2012. The gateway is new in R2. But notice on the vSphere side, if you want to do that network virtualization, the VXLAN equivalent, or the VXLAN, the network virtualization equivalent, you're going to need to use the vCloud networking and security SKU. So it's not in the box in vSphere. All of the building blocks are there, the vSphere distributed switch, the networking infrastructure, but you need to have the vCloud network security suite to get that VXLAN capability. Now, if I were thinking about my network strategy going forward and the approach of network virtualization appeals to me, I have to make a decision with vSphere. Am I going to go with VXLAN and start planning and deploying a VXLAN-based solution? Or do I want to think about something like Nicira, which was their acquisition not so long ago, a significant 1.2 billion acquisition to deliver a more advanced network virtualization functionality that stretches beyond just a vSphere infrastructure? I'd be I'd need to understand a little bit more about which approach VMware are going to go for going forward before I played my network virtualization card. But with Microsoft, you've seen what's in the box in 2012, and you've seen how we're enhancing it in 2012 R2. So, to wrap up the final section with high availability, not everyone realizes that Hyper-V and failover clustering is in the box for free with Windows Server and Hyper-V. It's in Hyper-V Server. It's in all editions of Windows Server now, Standard and Data Center. So the HA capability is there across the board. And it allows me to provide a level of resiliency for my virtual machines. If I lose a host, a physical host, VMs will go down, and they'll restart on another node in that cluster. There's no alternative in Hyper-V today and in R2 for VMware fault tolerance. If anyone's thinking that in the back of their mind, VMware fault tolerance, keeping 2 VMs in lockstep across 2 hosts, and if host fails, the VM is instantly taking over the workload, and then it clones itself again and carries on the sync. The problem with fault tolerance on the VMware side, 1 virtual proc per VM, maximum of 4 of those VMs per host, and you have to turn off a number of other capabilities when you're using fault tolerance. So it's great on one hand, but you have to sacrifice a few bits on the other. So it's great for certain workloads, but not for some of the higher-end, more performant workloads. However, there's nothing like that on Hyper-V. Okay, that's how it is today. To provide the closest level of resiliency in a Hyper-V world, we'd be looking at providing host clustering with perhaps guest clustering if your application supports that kind of configuration. But one thing that was significantly improved in 2012 and going forward in R2 is the way clustering handles significant failures. And when I mean significant failures, I mean a huge number of nodes going offline in one shot. Because we're frequently getting kind of ribbed by VMware around a legacy quorum model. It's not robust, it's not reliable, because if you lose a certain number of hosts, the cluster starts panicking and you're in a situation where HA kind of shuts down. Your VMs stay running, but you've no more resiliency. Not the case anymore. Firstly, clustering does not rely on Active Directory to be present when it boots. So we're getting over one kind of chicken and egg scenario there. Secondly, with this dynamic quorum, when you create your cluster of a certain size, this one's got 64 nodes in this case with some shared storage. Each node and the storage has a vote, and that's how clustering works. We maintain votes to decide quorum. Currently, with an even number of nodes, 64, and a witness disk, that'll be 65. It's an odd number of votes. Therefore, we use node and disk majority. However, if we were to lose a significant number of nodes, or just one in this case, we will automatically bring those VMs online, but we will also automatically adjust the quorum configuration to match the new number of nodes. So notice that the witness disk no longer has a vote, and just the hosts have a vote. So we've moved to node majority. HA stays up running. It's a more robust, it's a more reliable clustering solution, especially if you lose a huge number of nodes in one go. For instance, if a whole rack went out, all those VMs would fail over, and the quorum would automatically adjust. So you wouldn't find yourself in a situation where you're having to try to force quorum to get HA back up and running. So it's a lot more flexible, a lot more granularly controlled, and just significantly scaled as well with 64 nodes and 8,000 VMs. And as we said, guest clustering is becoming important. For organizations running SQL clusters or workloads that you do want to cluster at the guest level, as well as having the host clustering resiliency. 2 levels of clustering there. So if, for instance, we were to lose a physical host, the guest cluster other node stays up running, so the workload carries on going. And then when that VM comes back online, because of the Hyper-V failover, the VM cluster sorts itself out. So that scenario, the guest clustering scenario, is much more flexible now because the guests can use iSCSI to connect to the storage, so in-guest iSCSI through to the storage array. They could use virtual fiber channel, or they could use the network to connect to an SMB clustered file server or SMB share. There's full support for these cluster nodes for not only dynamic memory, but also live migration. So even though this is part of a guest cluster, I still want to be able to move it around my infrastructure flexibly. And that's important. We don't want to sacrifice flexibility. We want resiliency and we want flexibility. With VMware, you don't have that option. They don't support vMotion or memory over commit with guest cluster nodes today. But Hyper-V fully supports that. It also enables you to specify groupings around the virtual machines to keep cluster nodes apart, so anti-affinity, which VMware have got quite a powerful solution for as well. But that's been enhanced even further in 2012 R2. So that was 2012. In 2012 R2, with the new shared VHDX file, we can present a shared virtual disk that resides on an SMB share or on block storage, and those shared virtual disks that are presented to the virtual machines themselves, it presents itself as a virtual SAS disk, and there's an unlimited number of VMs that can share that particular virtual disk, and that provides the shared storage for that particular guest cluster, either the witness disk or the main disk used to store data, whatever it may be. And those can reside on block or SMB file shares. The beauty of that is you unlock the guest cluster from your own storage topology, and you don't need to present your actual physical underlying storage through to the VM directly. So it's great for service providers and multi-tenanted environments. And it can be a dynamic disk or a fixed virtual disk. As I said, VMware's got some great solutions for keeping VMs apart. So for instance, if that VM failed, we can now prioritize, both on vSphere and Hyper-V, the failover order of the VMs. So for instance, number 1 came up first, number 2 came up second. And in addition, if we mark a couple of VMs in what's known as an availability set, those VMs will be kept apart. So that if they were a guest cluster, you don't want to be in a situation where your guest cluster nodes are all on the same host. So that affinity, or that anti-affinity in this case, keeps them apart. So when we compare with VMware, we've both got HA integrated in most editions of vSphere now, not in the free edition. In the free Hyper-V edition, yeah, it's in there. Clustering is fully supported and completely the same as it is in Windows Server Hyper-V. The prioritization's there, the affinity rules, the NIC teaming is in the box. Wow, if I had a euro for every time people asked me about NIC teaming in 2008 R2, I'd probably have retired. But now, in 2012, NIC teaming is in the box. It's easy to configure, it's quick, and it's fully supported by Microsoft. So we move away from some of that confusion with third-party vendors providing that NIC teaming support, which you can still do if you want, but it's fully supported in the box and very powerful and granular and improved in R2. We both have an update mechanism in the box. Cluster-aware updating on the Hyper-V side, Update Manager on the vSphere side. When we start to look at some of the guest clustering, or in the host clustering as well, scalability, Hyper-V is huge. VMware's pretty big as well. But guest clustering flexibility is where Hyper-V really starts to come into its own, especially when you think about building guest clusters and using live migration and dynamic memory. Because on VMware, they're not supported today. And finally, when we think about local resiliency, we think about clustering. When we think about site resiliency, we think about replication. And Hyper-V Replica is an in-box solution that allows me to replicate across the network our VMs on a virtual disk by virtual disk level, and in the event of a disaster, bring those virtual machines up on a second site. Now, once that initial replica has been completed, we can just send the delta changes every 5 minutes today, and in 2012 R2, it's configurable to 30 seconds, 5 minutes, and 15 minutes. So 5 minutes today, 30 seconds, 5, and 15 in the future. And that gives us a lot of flexibility. These servers don't have to be the same on both sites. Our storage doesn't have to be the same on both sites. It's completely agnostic. That's the beauty of the software replication. And if there's a failure, we start those VMs up on the second site. But one of the other things that was introduced in 2012 R2 was this extended replication, where we've already replicated from primary to secondary, and now those same VMs I want to replicate to a third place. So we've got a lot of flexibility to provide that to perhaps another DR site, or if I'm a service provider, replicate it off to my DR site, having you already replicated to me. So flexibility, in this case, we've gone from SMB now to DAS storage. So you've got that 3 levels of replication in addition to the more frequent replication choices. So that's all in the box in Hyper-V. And when we compare that with vSphere, there's backup capabilities in both in-box, with vSphere probably having a little bit more of an advantage with their backup tool than Windows Server backup. But the replication, when we start to compare that, there's nothing in the pure vSphere hypervisor on its own. However, when we start to look at some of the capabilities that at the replication level, there's no separate appliance for Hyper-V Replica like there is for vSphere replication. It's asynchronous both sides, but Hyper-V in 2012 R2 offers a more more options around the RTO. When replication, A to B to C with Hyper-V. With VMware, you don't quite have as much flexibility. And this is the free vSphere replication, remember. This isn't SRM. With SRM, you get much more control and capability. But with Hyper-V Replica and the inbox vSphere replication, you'll see Hyper-V replication offering that little bit more around planned and unplanned failover, testing, setting IP addresses up in advance before failover. And if you do want to orchestrate that process of failing over from site A to site B, and you want to do it in a cost-effective way with PowerShell, the APIs are completely open. But with VMware, the only API that's exposed for orchestrating vSphere replication is exposed to SRM. So you have to buy SRM to handle that failover. With Microsoft, you can do it with PowerShell, you could do it with System Center, or you could do it with the new Windows Azure Hyper-V Recovery Manager, which we also announced at TechEd. So, that's a wrap-up. Apologies for running over very slightly. But we've gone through a huge amount of stuff there, and hopefully given you a decent amount of information on how things compare and contrast. I'm a massive fan of vSphere, I'm a massive fan of Hyper-V, and they're both fantastic platforms. But I think where we are today in 2012 and where we're going in 2012 R2, we're really delivering on scale. We're delivering some key multi-tenancy and security features. We looked at flexibility and how Hyper-V offers that little bit more around things like network vert and also things like some of the migration capabilities. And then we looked at some of the replication, the clustering, and some of the resiliency features around things like guest clustering as well. So hopefully you found that useful. I really appreciate you staying, and I hope you enjoy the rest of TechEd. So thank you very much.